Fiddle bump, fiddle bump, fiddle, fiddle.
Hello everyone, this is Ozil. Welcome back to my channel. So in this video I am going to explain how throttle resistance type sensors work inside, outside, and how get this ECM inside. Okay, so how is the reaction outside and how is the reaction inside. So totally I am going to explain, and also I explains Ohm's law and voltage divided circuit also, because voltage divided circuit and Ohm's law is very important to understand. So these alls are this is the throttle sensor, TP sensors, and this is the rail pressure sensor. It's commonly used in diesel engine, and this is used for petrol and diesel both also. Okay, so according to the cars and companies, I have seen in many ECM, in every ECM we will see and we have see this microprocessor MCU, one microcontroller and one power IC and one sys IC. Sys means systems IC, as you see here. So, and how circuit inside the board of TP sensor and rail pressure sensor and any sensor. So first I am going to explain you that this TP sensor, how TP sensor work. If you press the throttle accelerator, when you have a cable accelerator wire, if you have an accelerator wire, you can accelerate the accelerator, press the accelerator pedal on the time the outside of throttle actuated by mechanical wires, and this will be on off. So this is the resistance, variable resistance, and how it is work. First I am going to explain this voltage. Okay, so this is the 3 wires, 1, 2 and 3. So one is connected 5 voltage from power IC, 5 voltage from power IC, and one is connected to ground. Okay, one is connected to ground and another have connected to resistance. One is connected to pull down and another one is in processor. So how processor sense how you press the pedal, how much you have pressed the pedal on that time, how it get and how it know that. Okay, so that voltage I am going to explain, and how to find the any voltage, how to make the bypass and put it your own circuit. If you have a interested to create and design a new circuit, so you can learn from this video and you will make easily. Okay, so here you can, if you see the this sensors on the time, the internal circuit of this resistance, this sensor is like that. So this is the resistance, and here is the variable knobs. It is knob. If you turn this knobs on the time, it will move like that, here to here and here to here. Okay, so now I am going to first measure from A to B, A point to B point. Okay, so it's called the resistance. So here we have a multimeter, and the multimeter, one is negative terminals and one is positive terminals. Okay, and now I am going to measure it. You can see the resistance of this 5.3, the total resistance from here to here, the total resistance means this is like that. Okay, and from A point to B point, the total resistance is means RT. Total resistance means RT. RT is 5.3 kilo. I have put it in kilo. Okay, so this is 5.3 kilo. Okay, and now I will measure this point to this, means this point to this, how many voltage is showing, and from middle means A, B, and this one is C. So A to C and C to B, how resistance. Okay, now here I just make, and you can see here, you can see this is 4.9. so here in here this is the C point. So C point is our 4.9 kilo ohm, and if you minus this total resistance of A to C, you can get the B to C. Okay, so RT is equal to R1 plus R2. This is also one example. RT is 5.3 and R1 is your R1 is I don't know, and R2 is 4.9 kilo. Okay, so R1 is equal to 5.3 minus 4.9. So R1 will show you then calculator. Okay, so here 5.3 minus 4.9, you can see 0.4 kilo ohm. So the R1 value is B to C is 0.4 kilo ohm. Okay, so according to the Ohm's law, now I am going to explain according to the Ohm's law. If you have a resistance and voltage also, so between of resistance and voltage one current will flow. So what is the current? What is the current in this sensor, and how current take this sensor? So according to the Ohm's law, V is equal to IR, as you know that. Okay, and now I is equal to V upon R. So I am going to find out the I. Okay, the total resistance, the total value of R, and the total is equal to I is equal to V. Voltage I have applied 5 upon and the total resistance is 5.3. Okay, now we will define 5 divided by 5.3. You can see the current, the total current is 0.943. I'm not written full, but the current flow, the voltage flow 5 voltage in this sensors, and current flow 0.943 current. Okay, so now, so how many voltage if you connected only this section? So how many voltage here, how many voltage show if you connect, if you see the check the voltage on a vehicle, so how many voltage showing here? So you have to first confirm that in your theoretical. So now there is first step number 1, how we can find. Same I will apply Ohm's law. According to the Ohm's law is what saying? V is equal to IR. V is equal to IR. Voltage is I don't know where is the voltage here I don't know what is the voltage, so we will put remains, and current I know that where I can find it, 0.943 into R. We know that R means I have checked this across, because when we connect the multimeter, on first is negative terminal and second one positive terminal is to a direct signal wire, so we will check negative to this one. Okay, so now I will connect I will put the resistance value is B to C 0.4. So 0.4. So V is equal to, if we calculate, multiply this current and resistance, 0.943 into 0.4. So when we check it, so you can see the output voltage is 0.3772. Can see here. So this is the drop voltage. This is the drop voltage, because we have made that one mistake. So where is, you just opposite it. Samajh, let me A and B. So here this is 5 voltage, here is a ground, and the resistance here is C, okay, and the 4.9 is B to C, okay, and C to A is 0.4, okay. So if we put this value, this resistance, so we will see here. So actually this is wrong, because I have done mistake here. So our current is okay, this is okay, but we have done mistake here. So according to this, I will find V is equal to IR. So I is, we know that 43 I have find here, and into, we will put this 9 kilo ohm, 4.9 kilo ohm resistance, okay. So 0.943 into 4.9. So you can see here the voltage is here 4.6207, okay. Here if you check here, so you can see here 0.6207 volt, okay. So just a confusion, I have make here a mistake. That's why our answer is here, because this is the drop voltage. So if you add this voltage in this, the total voltage will show here 5 voltage, okay. If you add this one, okay, so this is the drop voltage. So you can understand this is the drop voltage and this is showing voltage, okay. And according to I'm going to take one more example. If you turn this to the 50% here, like that here, okay. So first we will check across this resistance, and after this two. If you have a confusion, so see again, okay. So we have 3 wires, okay, 1, 2 and 3. So I have check here. So 1, A, B and C. So A and B R A and B is 5.3, okay. And I will now turn this 50. Here you can see I turn this here like that. I have taking the accelerations. On that time the resistance value will change. पकड़ना तुझे बीच वाले, देखना हाथ डालना उधर से. So you can see the resistance is showing 2.3, okay, 2.3. So here is a ground, and here showing 2.3, okay. So 2.3, the circuit will work like that. Here is a ground, here is a 5 volt, and the resistance of from here to here is 2.3, and from here to here is 5.3. So now we will going to find the voltage, how many voltage are there, okay. So I will apply same formula, V is equal to IR. So voltage, we know that, we don't know how voltage. Current is 0.943 here into R 2.23, okay. So we will multiply this. We will multiply 0.943 into 2.3. The voltage is 2.1689 volt. If you just press the accelerator pedal, on that time this throttle sensor turn just 40%. On the time the processor get 2.1 volt, and according to this calculation, this processor provide voltage to system IC, and system IC fire increase the current of injectors and coils. Okay, so this is the whole function, guys. If you get knowledge from this video, please do like and share and subscribe to my channel. And if you don't follow me on Instagram, go and follow me again. So this is the same formula I also apply in another voltage, like a voltage divider circuit. Okay, we have done the Ohm's law and also check in voltage divider circuit. Page dena to. So now I take half one only, because I have to see. That's why. Okay. No, here we have a voltage divider circuit. What? We have voltage divider circuit. So what is the formula of voltage divider circuit? Is equal to V out is equal to V in into R1 upon R1 plus R2. Okay, this is the main formula of that. So according to this, here we have this one is R1 and this is R2. So I have a R1 value is 4.9 kilo ohm and R2 value is 0.4 kilo ohm. Okay, R1 is 4.9 and R2 is 0.4, and V in means total voltage. V in is 5 volt, means V is equal to 5 volt. Okay, so according to this formula I will put this value and how it will come. Okay, so here V in, I have V in 5 voltage into R1. R1 is 4.9. I have written here 4.9 kilo ohm, and now R1 is 4.9 plus 0.4. Okay, so you can see 4.9 plus 0.4 means 5.3 upon, do the multiplication of this 5 into 4.9. You can see here 24.5. Okay, and we will divide on 5.3. so you can see here the voltage is 4.6. so if you turn on the ignition and you have put it the connector on the scanner, on the sensors, and you will check outside the voltage, on the time you can get the voltage on signal wire 4.6 volt on signal wire. Okay, and this is the voltage divider circuit rules, and this is a Ohm's law rule. According to the Ohm's law, you can see here Ohm's law I have got the 4.625 and also 4.6, both are same. Okay, now I am going to take one more example for better understanding. Okay, this is also a voltage divider circuit. Okay, and the voltage divider circuit means what? I have taken this this wire, means V is equal to, I have a V 5 volt, and resistance R1 I have put it 0.3. so R2, our R2 is 3 kilo ohm. Okay, automatically we can find, because the total resistance R1 and R2 is equal to 5.3 kilo ohm. That's why. Okay, now we apply the formula. V out is equal to V in into R1 upon R1 plus R2. V in I have 5 volt into R1 is equal to 2.3 upon 2.3 plus 3 volt, 3 kilo ohm, sorry, volt 9, 3 kilo. This is 3 kilo. Now here is the 5.3 kilo ohm upon 5 into 2.3. 5 3 is a 15. Just 5 into 2.3, 11.5. And now I am going to divided by 5.3. Okay, so you can see here, if I divide from here to here, 2.1698 volt V out. So if you accelerate this on the time, you can see here the voltage will be remain same according to the Ohm's law and according to the voltage divider circuit. Okay, the voltage is same. Okay, so this is the very important to understand. If you understand this chapter, you can make video, you can make more easy to work, find fault finding. Okay, so guys, if you get the knowledge in this from this video, if you are a student or you are a technician, then please do comment in comment box. And if I done a mistake in this video anywhere, you just mention it. If someone saw this video and that have a doubt, so it will be take a view on comment, and it should be a clear. Okay, so thank you very much.